This video explains sales and operation planning idea. There are two different SOP strategy. First one is a level production strategy. Second one is chase production strategy. Level production plan will set same production level all the time, and inventory will fluctuate. A chase strategy case, we can set the same inventory level over a period, but however, production will chase their demand. There are two different ideas. And here we have a Pennington cabinet case. With this example, you can find this example from textbook. With this example, we have demand forecast. So demand forecast can be built by moving average, exponential smoothing, or time series or linear regression. So we can use these kind of ideas, and we have this demand forecast information. And also with this, we have some other planning values as well. I mean, production cost and average production information, and available workers, available work production plan, available production limit, and overtime cost, overtime information, also production hours and available production hours. We have all these information. And now we have currently 100 workers, and we have 100 cabinet here. And we want to end the planning cycle with these numbers. So it means our inventory should be 100 at the end. Also, our employee at the end should be 100. And for level production, and their production target is 840. So 840 is their average production level. And then based on this, we can compute layoff for hiring and the regular production, overtime, and the inventory level, all other things. So finally, we can compute the total supply chain cost based on all this information. To solve this kind of problem, we can use Excel spreadsheet. So Excel spreadsheet, you can download this Excel spreadsheet. From this, we have a sales forecast. Sales forecast is given, and also we have workers. Worker is 100, and the production level is given. Actually, this is actually 140, and all we have 840. That's fine. But also, if we have this 840, then what is our worker level? Our worker level is 140, and each worker has are available. Each worker has 160 hours available time. Then you can divide by 160. Also, it takes 20 hours. It takes 20 hours for each cabinet. That means if they have to produce 840, then their production, their workers' time will be 100 times. This is a production level, and each product, it takes 20 hours, and each workers can use 160. Then you can divide by 160, right? So then we have 105. So actually here you can use this information. This is actually production level times 20 divided by 160. So we can use this information, or you can use this information, either way. So anyhow, we have this information. We can compute our production worker level is 105, or you can use 840. So either one. So you can set this production level, then this worker level is 840 times 20 divided by 160. Then you can copy all this. So either way, so you can define this number. How? Basically, you can set up 840, and you can multiply 840, and you can compute this number, and again you can compute this number. So either way, anyhow, we have this kind of worker level and production level. This production level is given, so this is our fixed level. So also we have our worker level is given number. Then now based on this, we can compute the hiring and also layoff. For hiring and the layoff, we can compute the difference between these worker level. So for example, we have currently 100 employees, and in January we have to have 105. That means you have to hire 5 more people, right? So that means your hiring people is 105 minus 100, right? At the end, we have to set 100. At the end, you have to set 100. Then to do that, to compute the hiring cost, we can use the max function, max of your current number minus this number, and 0, max of this number. Then this means this number shows what? If you have a increase, then you can take that increased number. If we have a decreased number, we just take a 0 number. That is hiring. So in other words, in opposite way, you can compute the layoff. Layoff means you can compute previous period minus current period, and we can take a maximum number, a positive number. If they have, for example, if currently they have 100, and if they have 90, then 100 and then 90, then you have to lay off 10 people, 10 employees. That means you have to take difference between these two numbers, but you have to take a positive number, right? So this is your hiring and layoff. So you can compute this. Then all the way up to December, there is no hiring, no layoff. At the end, they have to lay off because in the problem said, this problem said they want to planning cycle with these numbers. That means your worker level should be 100, right? At the end, you have your worker level is 100. And also here your production target is 840 per month. So that's why you can set this production level is all the way up to December 840. In other words, your worker level is 105. So either way. So you can set this number first, and you can compute this number, or you can compute the 105, this number first, and then you can compute this production level. And if you have production level, and we have very basic supply chain equation, material flow equation, ending inventory, this equation. Ending inventory is equal to beginning inventory, previous ending inventory, beginning inventory plus production minus sales or forecast. That means we have this beginning inventory plus your production minus your sales. That is inventory, right? And we can drag this quantity, and we have finally inventory level is 100. So you can finish this 100. Then you don't want to have this 100 January, then you can change your ending worker level 100. You can put 100 here. That's fine. So either way, but anyhow, we have 100, but this should be equal to this. But anyhow, we have at the end we have five layoff. Then now we can compute the regular production cost, and we can compute the hiring, layoff, and the inventory cost. To do that, we define these numbers, right? So this number, so I just use this. I just define this unit cost information. To do that, you just highlight, and the formula, and create selection, create from selection. Then you can define this name. And now, so how can you compute the regular production cost? Basically you have to add all this production quantity, right? All this production quantity, which is sum, times your regular production cost. This is a regular production cost, which is $20 million. And the hiring cost is what? Hiring cost, again, sum of all these times hiring cost. You can select this hiring cost. And the layoff cost, same, sum of all these layoff times layoff cost. And inventory holding cost, you can add all ending inventory times inventory holding cost. Right. So we can use a dollar unit, and the total cost is equal to sum of all this. This is $20 million is your annual total cost. Also, when you compute this number, 840 is given, and you can compute this number. To do that, here you can use this average instead of this number. Simply this number times average labor hour. That means it takes 20 hours per each quantity, and each worker can use 106. So then you can divide by hours available. That is actually our required work level, employee level, right? So we can use this information instead of this 160 information. So we have done level production. Now next we can use a chase production level. For this chase case, we can set the same, our inventory level will be given like this. So for chase production, so here under chase production, Pennington set to inventory target of 102 set per month. But for some case, this is their average inventory level, but for the first 4 months they just use 102, but for the rest of the period they use 106. So this is actually their target inventory. So we said we just put this information. Now, so how can you compute your production level, your required production level? Actually, this is your target inventory. Then actually we know this. Beginning ending inventory is equal to, I will type here, ending inventory equal to beginning inventory plus production plus minus sales or forecast or sales, right? So with this equation, actually we know beginning inventory, ending inventory, also we know the forecast. Then we can compute the required production quantity. Required production quantity is equal to ending inventory minus beginning inventory plus forecast. So from this, so you can compute the production, required production. Production is ending inventory of each period minus beginning inventory. Beginning inventory is their previous inventory, right? Plus their required forecast. So required demand. Then this is actually their production level. So this is a production level, but however, there is some limitation of their maximum regular production hours. So actually here, maximum regular production hour is quantity is 848, but also they have allow overtime. Then we can, if they have more than 848, then it's overtime. They need some overtime. So to find their overtime regular production hour, then you can use this kind of equation. So R. So this regular equation is what? You have a maximum regular, and we can take a minimum of this max regular or your required production time. That is actually your regular time. So I will use this equation. Minimum quantity of max regular. So you can use max regular worksheet here, and we have this production quantity. So this production quantity is 752. That if this number is less than 848, then this is a regular production time. And if they have bigger than 848, for example, July, so July, their required production quantity is 910. So actually, you can have overtime quantity, right? So maximum regular time is 848, and beyond this, that's your overtime. Then what is your overtime? Overtime is actually your total production required time minus your regular time. That is your overtime quantity, right? So we can compute this. So and then we can recognize regular production time overtime production, right? So we know this. And then now we can compute the required workers. So to compute the required workers, we have to produce this quantity, and each quantity we have to use average labor hours, right? This quantity for each workers can use 160 hours available time. Then you can divide this quantity that is actually required workers. To produce 752, then you need 94 people, right? So this is basically, even if you have a decimal point, that's fine. This is an approximate number. Don't worry about that. And we can compute our approximate, worker level, and then now we can compute the hiring layoff. At the very first, in the current period, we have 100 workers. At January, we need only 94. That means you have a layoff, right? So you lay off 6 people, and next period you may hire 1 more people, and the next period you can hire 5 more people, and 3 more people, 2 more people, and so on. And at this point, they have to lay off, right? So then for this case, you can use the same idea. So you can use max for hiring case, max of your current employee minus your previous employee, and we will take only positive case. And for layoff case, you can use max and 100 previous period and the current period, and then we can take only positive point. Then we have a 6 layoff at the beginning, and so on. So we have this kind of trend. I mean, this is hiring layoff information. Then same idea. So how can you compute the regular production cost? So then we have a regular production cost. This is R column, R row, sorry. So this is your regular production quantity, and times you can multiply regular production cost. Right. And the overtime case, you can add this total over worker time, overtime quantity, and then you can multiply overtime production cost from this worksheet. And the hiring case, you can use a sum of hiring, sum of these all hiring. And at the end, they have to have only 100 worker level. Then you have to take into account the period. And at the end, you have to set to you have to have only 100 worker level. Then again, so you can compute, you can add all these hiring quantity, hiring people, and hiring cost. So actually, you have to use your hiring cost this worksheet. And the layoff case, you have to add all these layoff, and you can compute the layoff cost from this worksheet. And finally, inventory holding cost, you can add all this inventory level. So this all inventory level, and you have to multiply unit inventory holding cost. You can choose this one. So then now you can change to dollar unit, and finally total cost is equal to sum of all these. So then for chase strategy, you have a many layoff hiring costs, layoff hiring costs, right? But however, you can save inventory cost. Inventory cost is 50,000 for level production case. Inventory cost is very high, 114,000, right? But however, for this case, it's very stable. So hiring layoff cost is very small. Well, chasing case hiring layoff cost is a little bit higher than their level production. So level production case 8,000, 7,000, but chase strategy 34,000 and 29,000 for hiring and layoff cost respectively. So that's why this chase strategy is worse than your level production idea.